Please welcome Carl.
Hey guys, yeah, first of all, thanks for waiting. Sorry, I thought the timing was a bit different. Anyway, my talk today is going to be on my way to go Eth2.0. First of all, who am I? So I'm a researcher at the Ethereum Foundation. I've recently joined, and I'm working on sharding and proof of stake research. Today's talk is going to be a little bit different, I think, from some of the other mentorship sessions, workshops. Eth2 is not quite in the state where you can immediately hack upon it. I mean, it's quite strange to be able to say, like, go hack layer 0 or layer 1 stuff. That's very early. So I'm going to be talking a little bit about what you can do, some suggestions, and explain a little bit about where we are right now from the Eth2 perspective. So on to Eth2. First of all, if you are planning on doing anything Eth2 related, pretty much everything that we have decided or that will be implemented is within this GitHub repo. It's pretty useful. We've sort of reached our we've reached a spec freezes. We almost pretty much won't change phase 0 anymore, which is the underlying EDCON chain spec. And now we're moving on to some other more iterative things. There are still many undecided things. If you are looking at hacking on Eth2 or you would like to try your hand at something really different, these are some very interesting topics to give a shot. If you have opinions on any of these, there's a bunch more listed up there. But yeah, there are many undecided things. And if you have opinions and would like to contribute towards Ethereum 2, this is a great way to get involved. If you know anything about these topics, that would be great. So moving on, again, my presentation, I could give an introduction or sort of high-level explanation of what is happening, like how does Ethereum 2 work. I'm not necessarily sure that's the most useful use of my and your time. This is a visualization put together by Chih-Cheng, sitting at the back. This is from a typing presentation, and she has an excellent explanation on the life of a validator, basically what happens, how it works, how all the various systems plug in together. It's a very nice, high-level explanation, and it goes into depth nicely on basis. Which I think is very important. Education is something that you need to be able to educate enough developers on how such a system works. So for what I'm going to talk about today, I need to be able to explain a little bit about the technicalities of how Ethereum 2 works. And so here's a sort of rough state machine of what it is like to be a validator within Ethereum 2.0. So you have our sort of existing chain on this side, and to become a validator within Ethereum 2.0, you basically need to burn your money. So you send your money to this deposit contract, and it gets burnt. And using that, you can provide a Merkle proof and recreate yourself as a validator on Ethereum 2. This is how we have this separate chain, but still builds on top of the work and uses what has been done on Ethereum 1. So the Beacon chain, which is the central chain, which contains all of the information about how to manage the validators and how consensus is reached, that is intrinsically aware of the Ethereum 1 chain. And so we have this notion: if you want to become a validator, you send 32 ETH to this deposit contract, it burns it, you get created as a new validator in the Ethereum 2 chain. And if you have sufficient money, which in this case will be a 32 ETH deposit, you can become an active validator and start validating. From this, you slowly accrue rewards. As I'm sure you all know, this is where the proof of stake happens. You remain an active validator. And there's sort of two ways you can get out of that. Either you behaved honestly and you'll be able to withdraw your money, or you'll get slashed, as in lose a sizable portion of it. We also have this notion of transfers, which is something relatively new. This came out of an AMA that was done on Reddit a while ago. And transfers basically allow people to send an only ether between accounts or between validated instances on the Ethereum 2 chain if you are not actively validating. And so this is useful for in case you want to stop becoming a validator, but I'll get into a bit of exactly what would really be a useful thing you could do with this in a second. So I'm going to get on now to some cool ideas which I think really should be hacked. If you are not particularly happy with what you're hacking right now, or you think that you have some free time, or you would like to hack in the future on Ethereum 2, these are great ways to get started. And if you don't do it, someone eventually will, because most of these things can and should be done. So the sort of a very easy way to get into this is just visualizations. Right now we have this very complicated spec, and it basically exists as a single GitHub repo. It is very hard for people to understand what's happening, and even if you do understand what's happening, to see exactly how you're behaving as a validator, and that's very important. And so things like block explorers, we don't have block explorers yet. There has been the first starts towards block explorers. At ECC, there was some guys built something called Beekhuizen, which is a beacon chain block explorer, but it's still in its very early stages. And basically, if you want to build a block explorer, you have a chance to be sort of the Eth2 block explorer, or at least start the kernel that will become the Eth2 block explorer. And on the other side, some way of understanding what it means to be a validator and how you as a validator are behaving within the system. So if we could mimic sort of the feature you see on ETHstats or some of these other things that describes the mining statuses that we have right now, but do the equivalent for validators, that would be a very useful tool for people to understand exactly what's happening within our system, or within the system that's being built. Onto the slightly more sort of fun and challenging aspects. This is an idea which is going to be a bit fun. So within Ethereum 2.0, we have a slight difference to your standard proof of work system. So within proof of work, there is some probability based on your hash power that you'll be creating the next block if you find a valid nonce. And this means that if you wanted to censor the chain or do something malicious like that, you wouldn't know who to censor, because anyone who's mining could be the person to produce the next block. The best you can do is sort of assign your resources according to what you think the hash powers are of the various miners. But there's not much beyond that you can do. In Ethereum 2.0, we have a fundamentally different thing, and that is that you have some look ahead. You have some idea of who's going to be the next block proposer at a given slot. And this produces some really interesting problems, because it means that if you want to stop the chain progressing, you can see, look up who's the next validator, and then just go DOS them. And it costs you as much to DOS the entire Ethereum network as just finding whoever the next validator is. And so we sort of building the network on the assumption that you can remain anonymous, or that you can quickly change your internet connection or send your data, your signatures that you provided, via some other routing. And that may be the case, but that's not necessarily always feasible. So what I'm proposing here is to basically try and uncover that system, to try reverse this anonymity we have, where we don't know if you are validator number 1000, which particular computer you're connected to, what's your IP address, how do I DOS you. Whether this is actually a safe assumption to be making, or how much effort should we be putting into keeping these people private? How private are these validated instances? And so there are two real reasons why we care. I've been mentioning on the left sort of the malicious side of things, which is always fun, right? Breaking things is always cool. So you can prevent chain's progress, and we give rewards to including other people's the various work they do as validators, so including other people's attestations, that kind of thing. And we issue rewards for that. And so you can, if you see that, say I'm the validator in 5 slots time, slots equivalent to block heights, if you see that someone's validating 5 slots time, you can just DOS the 4 people in front of you and then steal all their rewards. So this would be, or steal all the rewards that those previous proposers would have received. So this would be a way to get some extra rewards. On the honest side, we do a trick which allows us to save a lot of data and quite a lot of time on signature verification. So instead of having each signature and storing it separately, for if you happen to agree with something, you can aggregate the signatures, which allows the signatures, you can basically add them up on the elliptic curve, and that still produces a valid signature. And so there's some very nice, efficient signature schemes, like my friends at Princess Research have put together Handle, and some other tree-based structures which would give massive performance improvements. But because we don't know who is linked to which IP in the network, it's impossible to uncover this structure, and so you can't efficiently aggregate. So if this anonymity assumption we're making is not really true, or it's not really an assumption, if it's very low effort to uncover this, then we can gain a lot of use out of efficiently aggregating signatures, because then we can stop pretending that everything's anonymous and hidden. And so here are sort of 2 proposals as to ways you could implement something like this. And right now, as there are no real extensive testnets running, we're starting to see the first testnets coming to use. You're probably going to have to simulate it. But if you would, you can perform triangulation, where you have a few nodes within the network, and by measuring the sort of timing latencies, the pings to the various nodes, you can retrieve this information. You can figure out where everyone is, sort of like a phased antenna array, if that means anything to you. The second thing is validators that they get assigned new shards, which they must have validators for. And by looking when new people join, each shard is its own little subnetwork. Like we have one large network for Ethereum right now, and we have subnetworks for each shard. By looking when people join this, you can sort of have some prior probability that they're this particular validator. And so you could try and de-anonymize people this way, although you have much less granular resolution than some trick like this. Whereas, I mean, if you're someone like Eth2.0 and have many, many nodes in a network, then it is quite possible, although I'm not really sure, to try and cover it. So a simulation that tried to do this would be very cool and very useful, I think, towards some of the efforts. Another idea, this is not something necessarily new, it's been proposed before, but I think would be very useful and has been sort of overlooked recently, is an anti-slashing box. So within Ethereum 2, there are some very strict rules as to when you can perform something that gets you slashed, when you will be punished for performing malicious behavior. But maybe there's an issue with your particular client, or you just happen to, I don't know, your machine turned off and you lost the data that was in RAM or something, and you forget. There is a chance, very small, but maybe by some fluke, that you would do something that caused you to get slashed. So some system like this, which is, it sits between your validator instance and the rest of the Ethereum network, and it intercepts all traffic that would get you slashed. It's fairly trivial to do because there are very few slashing rules. Again, if you're wanting to implement this, please refer to the spec to see exactly the ways you can get slashed. And basically, every single message that your validator tries to send out, you intercept that first. You check whether it violates any rules based on what's in the database. If not, you send it through and report it to the database. If it does, you prevent the validated data from getting slashed. This could either be some standalone device that you build and sell, and I can imagine if you have many, many validator instances, that it may be very well worth having some Pi box or something that does this for you, because you can never get slashed then. In other instances, you could build some virtual version of this and get clients to sort of attach it to the back of their clients, where it intercepts the traffic just before it leaves the client and performs these extra checks. this would be very, very useful for like, these kinds of preventions. Some other ideas. So within within proof of stake systems, you have this notion of weak subjectivity, which is where in a proof of work system, you always have an objective view of which is the head of the chain. If you have this set of consensus rules that you're following, you can always find this is the head via ghost or via the longest chain rule can basically determine which chain has had the most work done upon it. And this has a sort of objective determination of what is the head of the chain. This is not true in a proof of stake system. If someone presents you now with a few things that says one of these sets of blocks is the Ethereum blockchain, given a certain set of rules, you can arrive at what you think the Ethereum blockchain is. In a proof of stake system, because the validator sets are changing and they refer to themselves, you end up with these so-called long-term attacks, where sort of exited validators pretend they're not exited and sign as though they're not exited, and you have no way of knowing. So that's a subjective chain. Then you have this notion of weak subjectivity, which is where in the short term, your chain is objective, as in if you know right now the state of the chain, you can objectively determine what the chain head is, assuming there's no weird effects of network latency. But everyone should agree on what the chain head is. And then this period sort of is a sliding window that moves forward, and you can always within this window determine what the head is. But as soon as you fall out of that period, you don't really know. And so this is where the sort of subjective thing comes in, is you must ask someone else what they think the head of the chain is, get their information, and from then onwards you can objectively determine what it is. And that's very useful, but it's not something I think that's had much consideration into how they're actually implemented. So how do I check, if I'm wanting to join the network, how do I check that this is the valid chain? So it tells me the valid chain, who do I trust? Do you trust Vitalik? Do you trust large companies? What if Infura tells you something else? These kinds of things. And it would be even better if you could do this in some automated, by some automated mechanism. So to the best of my knowledge, none of the clients that are implementing this stuff have tried to have some automated mechanism for this. But because the Ethereum 2 chain is aware of what the Ethereum 1 chain is always doing, it's part of the way we allow these transfers to become a validator on Ethereum 2. We could create a system where people sort of, you have smart contracts, and people attest within these smart contracts to what they think a valid head of the chain is. And so in these instances, we have two competing Ethereum 2 chains, but you can go to Ethereum 1, which is still objective, and based on these votes, you can see, okay, these three people indicate to this chain, so you can run a sort of consensus agreement or have some sort of bootstrapping mechanism that agrees that you can trust however many people, and that will allow you to determine which is a valid chain. Notably is that these people, although they agree, they're not attesting to the head of this Ethereum 2 chain, and that is that you only have to get one update per week subjectivity period, and so you only need these people to tell you within some band of time what the head is. And so as long as they all tell you the same information within the same band, you can reach consensus with them. And so a system like this would be very useful, because right now, if, say, 6 months down the line, you decide, okay, cool, this whole Ethereum 2 thing is pretty cool, I want to become a validator, I want to join the system. I'm not sure, but to the best of my knowledge, no client will automatically say, okay, cool, this is the head. Or at least not in a somewhat trustless manner. Here, you could build in a system that trusts a bunch of people in the space that you deem trustworthy, and from there, you automatically determine what this is. Proposals in the past have wanted to use Twitter for this, but then of course you're relying on a centralized service that is Twitter. Another thing which would be very useful, so previously I mentioned that there exist transfers within the Ethereum 2 Beacon chain. And the purpose of these transfers is people would like to be able to not just become a validator on the Ethereum 2 chain and be stuck being a validator. But as the system exists right now, you can send money from the Ethereum 1 chain over to the Ethereum 2 chain, and within the Ethereum 2 chain, you can send money between validators as long as they're not active, but there is no means to get any assets from the Ethereum 2 chain back to the Ethereum 1 chain. And so that's sort of what I'm trying to represent here, is that there's no sort of backwards compatibility. And so there are there's proposals to write light clients for Ethereum 2 in Ethereum 1 that run in Ethereum 1, or using sort of a similar mechanism that I was proposing earlier, with people attesting to what they think the hit is, or even just if you can get Alice and Bob to agree on a valid finalized block within Ethereum 2, then you can get them to trade Ethereum on the Ethereum 2 chain. So you aren't actually sending money back from Ethereum 2 to Ethereum 1, but you can get Alice has got her beef on Beacon chain, ETH is beef, by the way, sorry. You can get Alice has got her money in Ethereum 2 to exchange that, sort of how we do wrapped Bitcoin or wrapped Ethereum or some other mechanism that I'm not sure maybe you want to come up with, that allows for the exchanging back to the exchanging of assets between these two chains. And that's going to become very important for ensuring things like Ethereum, the Ethereum that we have on Ethereum 1 and this Beacon chain ETH we have in Ethereum 2 are at all times equivalent 1-to-1 and don't fluctuate. And just that people don't feel like they're stuck on Ethereum 2 forever. Although we intend to move everyone over to Ethereum 2, right now there's no means to come back, or the money you have on Ethereum 2 is not something you can immediately spend. Once you send your money there, there's no exchanges you can send it to, although a system like this may allow for something like that. Anyway. This is another sort of, it's a bit of a pet peeve of mine that actually exists in the spec right now. I'm going to have to bring up some code, I think, to explain it properly, but given the spec as it currently stands, you can write a calculator with very minimal effort that will allow people to increase their rewards quite dramatically. So within Ethereum, within the spec right now, within Ethereum 2, we use the so-called effective balance of each validator, which is defined loosely as that Python function on the right there. And as you can see, there's a mistake in my slides, apologies. I should say the minimum of those two balances, but basically it takes the minimum of either the validator's balance or 32 Ether and issues rewards based on top of that. The effect of this is that if you were to have, say, 35 Ether because you've been staking for a long time and accruing rewards, that your reward, you're still given a reward as though you had 32 Ether. And so your growth sort of is this linear function, assuming you started at 32 Ether, your growth, your validator balance would be this linear function, whereas I think most people expect it to be this exponential growth as however much percentage returns per year you can get. And so one interesting way of fixing this would be to do something that creates new validator instances. So if you are, this calculator would take in the current balances of your validator instances, the number of people trying to exit, and the current fees for transfers, which you can sort of think of as gas costs, but it's not quite gas, but the gas cost to sort of transfer within the Beacon chain. Exactly as a function of all of those three things, how frequently should you exit? So you can as an active validator, all your validator instances. Say you had 10 instances, and they've now each reached 35. You've been staking for a long time. You've gone up from 32 ETH to 35 ETH in each of these validator instances. You can then exit all of them and create an 11th validator. And this 11th validator instance would then sort of allow you to have linear growth, but basically 11 instances. And you end up with this sort of green line, which approximates the exponential growth that you have over there. And a calculator to do that, I think, would be very useful. So this is sort of issuing instances, new validator instances each time an individual validator gets 4 Ether, which is probably a little bit on the low side. But again, you could try various other schemes. Anyway, that's been what I'd like to talk about. What I think you guys really should be, well if you would like to hack for Ethereum 2, try some new interesting things. Those are some of the challenges I think would be interesting to tackle. Are there any questions, either on Ethereum 2 or on some of the ideas I presented for hacking either today or in the future? No? No? Yes?
When can we expect phase 1?
What are you looking for phase 1? You want a spec freeze, because I know you're doing some coding on top of the spec there. You want a spec freeze, or are you saying when are we launching phase 1? What are you interested in there? The blockchain, that I do not know. I think it's unlikely you're going to see phase 1. For those of you who don't know, phase 1 is when you start putting data into the shards. I think it's unlikely we'll see that within 2019. We will require the spec to stop changing. There's still a few things that are undecided, although it's getting close. And then, of course, for the clients to implement that and to test that and get audited. I think it's very unlikely we'll get that within 2019. I would be very happy if we could get it within 2020. Again, I do not know. I don't really want to speculate on those things. I think there are many things that could have large effects that are unforeseen. Any other questions? Yes.
Who should we reach out to when we work on any of these ideas?
If you work, please hit me up on Twitter if you do work on any of these ideas. I'm really interested. Love to work with you or help you out if you want. Hit me up, or if you have anything that you think is going to massively change, if one of these ideas you think breaks any of the systems, post it on ETH Research if it's more ETH research related, or put it on the specs, GitHub, Ethereum/ETH2 specs as I showed earlier. Alright, thanks very much guys, and good luck hacking.